So my project is based around an ice core that's on the Antarctic Peninsula at the Bruce Plateau site. And the overarching goal, I guess, behind it is to look at the accumulation rates, the very high accumulation rates that were there. Because when the team went down to drill it, they realized that every night, tents were being buried by snow. They set up a 10-meter meteorological observation station there, and it was buried in 4 months, so 4 or 5 months. And they wanted me to really look at when the accumulation happened, if while they were there, if that was an anomaly or if that was a normal event. They wanted me to look at kind of the accumulation monthly throughout the year on average, and I did that by looking at the isotopic delta 018 values, the record of the core that I had helped from a PhD student who helped run the tests and helped pretty much facilitated the comparison that I made. So I compared it to the temperature values from nearby stations that have very similar weather patterns, I guess you could say. So here's a graph of the temperature isotopic comparison. And as you can see, it goes from when the core was drilled, which is late 2009, early 2010, back until 1996, when we had station data when this project was started. And as you can see, the black line is the temperature data for one of the stations, and the red line is the isotopic record. And I had the PhD student and I came up with rough January 1st for every year. And from here, all the isotopic values were kind of fit or to the temperature data, calibrated, that's what I was looking for. They're calibrated to the temperature data. And there are some places where it's a good fit. So from here, we came up with accumulation rates because the more close the isotopic values were to each other, the higher the accumulation was. So that's how we came up with this graph right here. And as you can see, it's what we somewhat expected. The highest accumulation rates happened in the springtime, August to October here. And then the lowest again happened in between January and March. And from here, I also looked at the correlation between the two stations to see really how well the two stations recorded the conditions in the area. And it turns out that the two stations are very well correlated, as we can see in this graph right here. The Rothera is on one side, and the Vernadsky station temperature is on another side. And as you can see, the R-squared value is very high. It's 0.865. The correlation coefficient, I believe, is like 0.93. So they are very well correlated, which is why we only have one temperature plot on the graph, because the other one was pretty much showed the same thing. And I guess from here, for future work, in the next few months, I'm going to be looking at extending this record, the isotopic temperature calibration record, back until when I had data, back until the station data started. So Rothera was started in 1978, so I'm at least going to go back until 1978, so I have both station data. I can also, since the correlation is so high, I could also go back until, I believe, 1948, when the Faraday station was started. So I'm going to be doing that. And then another thing I'm going to be doing is I'm going to be looking at the anomalies here. So that this bar right here is April of 2008. So I'm going to be looking at months like this, or months like June of 1996, and again in August here. I'm going to be looking at those months. I'm going to be looking at like the precipitation data, the wind speed and wind direction for the different stations. I'm going to be looking at the rain analysis data of the area to really see, what was going on, if they did get very high accumulation events during those months, to kind of confirm what we got from the isotopic record here. So, and then another thing that I'm going to also be looking at is the correlation plot here. As we noticed, the warmer months have a much higher correlation than the cooler months. So I'm going to be looking at really why that is. I'm going to be looking at different scenarios of why that could be. And hopefully in the future, with this isotopic temperature comparison plot, we can go back beyond, we can extrapolate it back beyond before we had the temperature data, if we find a good enough fit with the isotopic record. So that's an overarching goal also, and that's my project.
Okay, so that's really interesting. How long did it take you? Like, how long did this project go on for? About?
Yeah, so I started this project. I've been working with my research mentor for a few years as an undergrad, and I worked on several different projects with her and with the group, and I started this project. I really started it when I came back from my summer internship in the fall. I really started to work on it. I did some work on it in the spring, but not too much. In the spring, I pretty much got the temperature and organized the temperature data.
Okay.
But in the fall was really when I started to do the grunt of it, or do the meat of the work. And yeah, so I've been working on it for about a few months now, several months. I'm going to keep working on it until May when I graduate, and hopefully I can keep working on it if it needs further work after that too.
Right. Okay. So what did you learn about yourself doing this project, about the kind of research you maybe want to pursue in your master's, or if you decide to do like on the job work, like what did you kind of learn about yourself in that?
Yeah. So I guess this summer I did policy research, which I love doing, climate policy research. I worked with a local program, a local climate program in Colorado, and I love that. I know I really wanted to do that, and then I came back and I really got into this research, and I found out that I love doing paleoclimate research. So in the future, in the near future, I'm going to grad school, hopefully, fingers crossed, and I want to work on paleoclimatology work, whether that's with ice cores or sediment cores. I just want to keep doing that. I find it really interesting, being able to, learn about climate before, any of us were here. So I just find that really interesting. And then hopefully in the future, in the long-term future, I want to, I think being able to explain, or being able to get our message out, what we're doing in research, what we're finding in research is, key. It's critical nowadays to get that to the public and be able to have the public understand what we're finding. So I really want to get into climate policy as well. I don't know on what level yet. I really like the local level. I haven't really done anything on more of a large scale level, state or national maybe, but I would love to do policy work surrounding climate change, or surrounding my research here. So I guess those are short-term and long-term goals.
Okay, so yeah, that's awesome. Well, you had a great project, and thank you so much for your time.
Thank you very much.